Hello, everybody. For those of you that don't know me, my name is Russell Herbert. I work for OSIsoft. I'm based in the UK, and I'm absolutely delighted to be here today talking to you on the subject of operational data management. Okay, so the first question, I guess, on everyone's lips at this moment probably is why are we talking about operational data management? This seems a pretty dry conversational area, something that not all of you are particularly that interested in. Well, I think, in my opinion, this is a really important topic that is actually often overlooked. We've been talking already today during the conference, and there'll be a lot more presentation material to come over the next couple of days, talking a lot about new applications, new areas of analytics that we're very interested in, new things that we want to be doing in our refining and our downstream operations. And I think it's often an overlooked area of how we are actually managing our operational data to make sure that we get the most value from all of these systems and new tools that we want to be using. We've been collecting data for a long time in the industry now. We've been using it to help us run our plants and our processes. And maybe there's this sort of feeling that we already understand this topic, or we're already getting the most out of this, and that we're so focused on all the new stuff that we aren't potentially thinking enough about, do we need to revisit the way that we're collecting and managing our data to get the most value from it? So what I'm hoping today to do is to give you just a brief overview of some of the areas that I think that we would all value by looking at a little bit more closely when we're setting out on these new digital journeys that we're trying to do. But in order to look at maybe how things have changed a bit, or areas of our operations that we should be focusing on perhaps a little bit more around data management, I think it's first important that we have a look at how we've been using, collecting, working with real-time data over many years now as a basis for that change. So I think we're all familiar with the idea that across our refineries, we have lots of pieces of equipment that are collecting data, sometimes consuming data, moving data around, pieces of information that we're interested to get hold of and work with. And I think we're all generally quite comfortable with the idea that the way we do this is by connecting through typically our process control networks to a piece of technology called a real-time data historian. And what do we do with this historian? Well, the historian is very good at collecting all this data for us, long-term historical databases, in many cases going back many years of data, many measurement points, often every second or every 5 seconds, lots and lots of information. And typically what we see across our downstream customers is you're going out and buying a range of specialist tools or building specialist tools yourself that rely heavily on this operational data. And our technical teams do a fantastic job of connecting this historized tag-based data in our data historians to all these applications. And in the applications, I'm talking about models, I'm talking about simulations, I'm talking about tools to help us maximize yield, manage emissions, help us manage import and export out of our refineries, etc. So this is all very common. And on top of this, we would see the manufacturers of the historian software providing technology for us that help us visualize these measurement points over a period of time, trend analysis, and also create process display screens, much like we see in our process control DCI operator stations, that allow us at any point in time to view the real-time data coming from our refinery. And on top of this, we would also see typically within our operational environments, the ability for our engineers to connect to those historians and take data out of them into tools like spreadsheets so they can do ad hoc analysis and investigation into things that are happening. So this is all very familiar. But if we look at a modern downstream operation and we look at the kind of things that we're talking about during this future downstream event, increasingly we recognize that customers want to do a lot more with data. They want to start connecting these business systems, these maintenance tools, these engineering tools, their finance tools, increasingly to these real-time systems to get more value. And on top of that, there's a real appetite to do stuff with the advanced analytics, the digital twin, the advanced business analysis tools, dashboarding, all the fantastic new bits of technology and systems and tools that we hear about every day. And on top of that, there's also a lot of interest, or invariably conversations on these topics start involving cloud technology. Not everywhere. We understand completely that there are regional sensitivities around cloud systems, But generally, we find ourselves, when we're talking about analytics and digital twins, having conversations about how do we go about moving all this historian data, often very large sets of data that we have in our refineries, up into the cloud. And I think it's really important that when we start thinking about all these things, we ask ourselves the question that is the traditional historian tag-based systems that we've been using for many years, is it really fit for purpose? Is it helping us or preparing the data for us so that we can properly take advantage of all these systems and all these tools? And I think experience has taught us in OSIsoft, and certainly the industry is increasingly realizing that the answer to this question is no, and that modern real-time technology, the most advanced real-time platforms that are out there, such as OSIsoft's Pi system, have had to evolve significantly to make sure that customers like yourself can get the most value out of all of these tools by ensuring that they're properly managing the data up front before it goes into all these systems and tools. So today I'm just going to introduce 4 areas that I think we need to be thinking about a little bit more. And as we're setting out in our projects and programs to explore what we can do with digital twin, advanced analytics, all these new things that we want to explore, my recommendation is that we also spend some time within our companies or working with the technical experts that we work with every day, just to make sure that we're doing, we're giving equal attention to how we're managing the data that we're feeding into these systems. So what are the areas that we need to think about? Well, the first area, and I think the most important area, is the area of context and structure, making the data meaningful. So what is it about historian data that is different, and why is this such an important topic? Well, the main thing that we need to remember is that traditionally, historians lack any sense of context and structure. Because historians have had to be very high-performance data structures, the data within them is really rather flat. So what I mean by this is that, if you look under the hood in a historian, really all we're looking at is measurement points, a timestamp, and a value. There's no concept within most historians of what that data actually relates to. Is it a pump? Is it a compressor? Is it a turbine? Usually all of this kind of stuff is missing. And because it's missing, it means that we're very reliant on our engineers and our operations team knowing exactly the information they need from the historian. Now, that's fine if you're an expert and you're used to working with this equipment all day, every day, and you know exactly what the tag reference or the sensor measurement IDs are that you're working with. But that's a real problem when you start thinking about that we're trying to move into a world where suddenly this data is exposed across our entire organization, and that we want everybody in our company, where appropriate, to start getting value from it. Having this data sort of hidden behind tags that are really not meaningful and can be really confusing to many people is certainly a roadblock to getting the most value from all this data. On top of people having a problem getting access to this data, increasingly we're trying to work in a world where systems and tools and complex applications are integrated together and synchronizing together in an automatic and powerful way. And not only do tags mean that people can't come to this historian data and quickly find what they're looking for, it means exactly the same for systems and other applications. A traditional historian, there is no mechanism for a tool such as a digital twin or some other system to be able to come to that historian and quickly interrogate and find information about what the contents of that historian is. In other words, if I want to say, show me an information, do you have information about a certain pump or a compressor? Do you know about this heat exchanger? Can you give me the information from it? Generally speaking, those kind of capabilities are not possible in a traditional historian, which is a real problem. It also means that the integration between historian and systems traditionally has been sort of stitched together by the techies in our IT departments, who do a fantastic job. But as we move into a world with more systems, more applications, more tools, with more things changing all the time, we really start realizing that this manually stitching together tag references to systems isn't scalable and is actually holding us back from what we're trying to achieve with data. And the other problem that we've increasingly recognized is that with the lack of context and structure in our real-time data systems, when we start moving this data into the advanced analytics platforms, we can't get away from the fact that we still need to introduce context and structure. We can't expect an analytic program to do some sort of analysis on the data and tell us why our pumps are failing if it doesn't have the ability to differentiate between data from pumps and data from other pieces of equipment in our refinery. So it's not really a question of whether we need context and structure with our operational data. It's really a question of where do we introduce this, where's the best place to do it, and what's the best way to support transformation across our entire organization. And my recommendation would be very much that the best place to do this is as close to the data as possible, as close to the operations teams who are experts at that, within the data layer or the enhanced historian technology that you have available in your refinery. And the way that this is typically done is to introduce the idea of a data model or some kind of data structure on top of the raw tag data. So what might this look like? Oh, it's not moving forward. Here we go. Okay, so if we imagine that we've still got our traditional historian collecting all this data underneath it, but as we've talked about, the problem with this is there's no context or structure. So if we look at the most sophisticated real-time technology out there, such as the PI system, what we will find is a layer that sits on top of this, an operational data model that allows us to introduce the idea of data definition and structure to our information. And what that immediately means is that people coming to this data no longer have to rely on understanding what what the tag references are and what the raw data relates to. They have a framework where they can come, and anyone in the organization can look at this and find access to the operational data in a meaningful way. So introducing that context and structure is a really powerful way to make this data available to an entire company. But more than that, it gives us the ability to expose this data to analytics tools, digital twins, data lakes, whatever need access to this information. Suddenly, they also have the ability to come to the historian or the data platform, ask the questions they need, and get the information they want. And I'm going to give an example of this using digital twin, which I know is something that everybody is very, very interested in. So if we imagine a typical digital twin implementation, we've got our physical plant and we've purchased some fantastic piece of digital twin software, and we've started linking in all our operational data, whether that be maintenance data, PNIDs, 3D drawings, all the typical things we find in a digital twin. And this is fantastic. Now, it's no surprise that we often find customers coming along and saying, well, look, we have all this operational historian data as well, all the sensors and pressure values, temperature values from across our refinery. We want to bring this information into the digital twin as well. And, people have done this and stitched together manual tag references into these digital twins. And we've seen proof of concept, we've seen demo systems working, and there's no doubt it looks fantastic. It's amazing. But the problem we have is that, as we all know, within our refineries, within our industrial assets, there's lots and lots of change. Maintenance is occurring regularly, unplanned failures, downtime, these kind of problems. And so what happens is that things that have been manually stitched together and that work on day one soon start breaking, or references stop working. And, as much as the IT guys and the people administrating your real-time technology try and keep up, invariably it's very, very difficult to synchronize that amount of change with the real-time technology. And so people stop relying on this information because they can't find what they want, and they think the digital twin isn't delivering the kind of value they need. Now, if we move into a world where we suddenly introduce the idea of context and structure, things are much, much different. Suddenly we've got the ability where the digital twin software can come to the data platform and ask us questions about context and structure. We've just added a new pump, someone's just changed this, a compressor's just been added into the refinery. Do you have this data? Can I, remove the old reference, add in the new one? Suddenly, if we have context and structure in our real-time technology, we've got the foundation that we can start properly working alongside tools like the digital twin and the advanced analytics. And so introducing context and structure into our real-time technology is a really, really important step to achieving digital success. So the next thing I want to talk about, the next topic on top of that, context and structure, is the idea of enhancing and integrating all your operational information together. So our digital industrial environments have got significantly more complex. Compared to where we were 10 years ago, suddenly we are in a world of many different types of models and simulations, physics-driven, data-driven, many, many different types of applications, creating predictive insights for us, or future suggestions or predictions of what may happen in the future. We've got many different types of tools. We've got streaming analytics that we're doing on top of the data we're measuring. We've got references to other systems. We've got links. And I think one of the important things when we're building our real-time data strategies to remember is that all this data and all these fantastic tools need to be integrated and brought together in a way that can be exposed to our operations teams and can bring value at an operational layer. In other words, it's great that we can take data, send it into some predictive tool and have some insight done, but we really need that insight brought back to the operational layer so it can be put alongside that real-time data and can be presented to operations so they can perhaps start comparing what was predicted against what was happening, or automatically start reacting to problems or issues if we're diverging away from how we're expecting the plant to be performing. And so how we recommend this working is, on top of that context and structure and the data model that we were just talking about, modern real-time technology also provides us the mechanisms to enhance those data sets over and above just what we're measuring, and start introducing links and references, kind of tendrils that we can put out into all these other systems, so that we can not only send the data out that we need, but we can bring the results back as well, and have a single point of truth where an operations user can come to this and say, in regards to my time series plant data, I can see in one place in the data platform, not only what I'm measuring, but all my predictions, or my simulations, or my calculations, or my KPIs, or my metrics, or my metadata, everything that relates to this data, I can see that in one place. And I think investing the time to build these things out is a massive step to being able to realize the full value of all your operational data within a modern refinery. So certainly worth something we should be doing. The third area I want to talk to you today about is the idea of spotting and reacting to operational events. Again, traditionally we've been working in a world where not only we are connecting systems via tags, but we've also generally been working in a quite reactive way, where problems or issues occur, and then we go back and sort of look at the data. And what I'm suggesting today is, if we're moving to this world of far more digitally advanced operations, we know we're going to be working with a lot more data, much greater volumes, much higher velocity of data running through our refineries. And so we really need to start using the power of these modern real-time tools to spot operational events for us and automated responses wherever possible. So if I know that there are certain problems when temperatures do this and pressures do this in my plant, or when certain combinations of data start occurring, don't rely on people to sort of sit there and look at the data and spot all these events, because that's just simply not going to work. Use the power of these tools to automatically spot this stuff for you and react in whatever way you think is appropriate. And this is a really, really powerful way to start introducing the idea of event-based or exception-based surveillance into our downstream operations, and certainly something we see from most of our most advanced operators. Not only do we have the benefit here of being able to spot things automatically and react to them, but the other thing that we also do is we introduce the idea of the behavioral context. So if we've been talking about context, i.e. descriptive context, what is the data relating to? If we want to start using this data for analysis, we also really need the idea of some sort of behavioral context. So not only do we know it's a pump, but we know that pump has failed, or we know it's just starting up or just shutting down, things that we're introducing to in analyzing. And by using the power of the real-time data to spot these events or look for things that are occurring in our plant, we can create those contextual slices of data automatically and use them as something that we can feed into those analytic tools. So again, investing in this kind of event-based monitoring of stuff automatically in our real-time technology is a really important step to getting the most value out of it. And the fourth and final area I just want to touch on today is around data quality. Now, I think we all recognize the idea that bad data in is bad data out, but it's far more. There are more implications to that than just that simple, that simple sentence. We need our operations teams. If we're moving into a world where we've got all these analytic tools and systems sitting around our data and being fed them in real time with the information coming from our refineries, we need to understand when the data is good and when the data is bad. And we need to, in real time, be able to inform our operators when they should be trusting those analytic tools and when they shouldn't be trusting those analytic tools. On top of that, a big part of this kind of predictive world we're moving into is the idea of training our models. We need to make sure that we are regularly feeding the models with new data, good quality data that they can use to train and learn more about the way our plants and operations are working. So again, it's very important that we understand the quality of data so we can make decisions about when is the right time to train models on data and when is definitely the time not to train them, i.e. when the data is bad or can't be relied upon. So again, explore the capabilities in your real-time technology, understand what you can do around data quality, and make sure that you're really making the most value of these areas, because there are fantastic capabilities in these tools now to define rules on the data that can spot bad quality events, alert the operations teams to problems, automatically switch between when you use the data, when you don't use the data. Use complex mathematical modeling to be able to recommend better quality alternatives or fill in the gaps in the data, those kind of problems. So it really is worth exploring this stuff and making sure you're getting the most value out of it. And I want to just give you two quick examples of what I think really represents best practice when it comes to real-time operations. So the first is a customer of ours and great friend of ours, Petro Rabik, who are based in Saudi Arabia. One of, if not the largest, single-site petrochemical and refining plants in the world. And they've been a long-time user of OSIsoft's Pi technology and have really been embracing all the kind of topics we've been talking about today, as well as many more on real-time operations. And during their time, they've really unlocked significant values, really empowered their operations teams by putting this kind of context and structure and event-based surveillance and automatic analysis and integration of all their tools in the plant together to maximize the value from they're getting there from the real-time data. So I would recommend, if anyone's particularly interested in their topic, in their story, either let me know, or if you go to our website, www.osisoft.com, you'll be able to watch their presentation themselves and really understand what they've been doing with real-time data. And another story of great success is the MOL organization, the National Oil Company of Hungary, who've been a really advanced user of real-time technology in their Danube refinery for many, many years. And they have gone on record on many occasions talking about the value that investing in really good quality operational data management has brought to their plant or their refinery. And in fact, they've even told stories of over a 6-year period realizing more than $1 billion of EBITDA savings in their operation, which is a fantastic story. Now, of course, not all of that is entirely related to what they've been doing around their real-time operations, but many, many wonderful stories of transformational use of real-time technology to improve the way they're operating, maximizing their yield, improving safety, helping them with crude blending, all these kind of problems. Fantastic stories. So again, if you're particularly interested in the MOL story, please let me know. I would be more than happy to tell you more about it, share with you the presentations, and let you know all the wonderful things they've been doing around some of the topics we've just been touching on today. So I'm almost at the end of my slot, but the final thing I really wanted to mention was that if this is a topic that you are interested in, and I recognize we're only just touching, with only 25 minutes, we can only literally skim on the surface of what's possible in the world of real-time operations. But if you are particularly interested in this topic and maybe are interested to know, where your organization is, and maybe where the areas of improvement could be, or maybe where you are against other organizations in your industry, then please either let me know, let your OSIsoft account manager know, or your customer success manager, if you're a customer of ours already, please let us know, and we would love to sit down with you. And we have mechanisms in place now where we can run you through some sort of operational data management maturity framework to really give you some insight into this information and tell you, maybe what you're doing well with operational data management and maybe some of the opportunities for improving. And I passionately believe that by spending more time on this topic and focusing a little bit more on what's possible, I think we will all find that the really exciting applications and analytic tools that we really want to bring to our refineries, the value we get from them and the success we have using them will be significantly magnified. And we've got many, many stories of exactly that across the industry, not just the MEL and the Petro Rabik I've been talking about today, but many from across the entire industry. So I would say at this point, thank you very much for listening to my short presentation. Again, very short, but hopefully something that's caught some of your interest and something that you would like to discuss with me further, discuss with OSIsoft further, and hopefully an area that you can do more with in the future. Thank you very much, and enjoy the rest of the agenda, everybody.